Hey Bella, so here's how you do number 36. So they start off the problem by telling us that the tangent of B is 3/4. So opposite being 3, adjacent being 4. However, we know that different triangles that have this angle, but that are similar triangles, can have different leg lengths. That this is just the ratio between the legs, right? That the ratio of the opposite leg is a 3 and the ratio of the adjacent leg is 4, and that they're 3/4 in proportion to each other, right? But we don't know the actual lengths of bigger and smaller similar triangles. We don't know the actual leg length. So we're going to pretend that some mystery triangle, we can just make the little like triangle up here, is the actual 3/4 triangle. Because evidence we're given here already starts to preclude the big triangle from being the 3/4/5. We know the big triangle can't be 3/4/5 because the hypotenuse of the big triangle, well, it's 15. So we know it's not a 3/4/5 triangle. Again, I'm mentioning 3/4/5 triangles because they're telling you that if you have one is a 3, one's a 4, and you know it's a right triangle, the other side must be a 5. So we know this big hypotenuse here is a 15. And we know that on some planet, like this imaginary triangle here, B opposite is going to be 3, adjacent is going to be 4, hypotenuse is going to be 5. So not necessarily this one's, of course, certainly not down here on DE because they tell us like we're solving for DE. We don't know for sure what the length of this bigger triangle, the side lengths of this bigger triangle, or this bigger triangle aside from the 15. But then they bring in a really important clue. They tell us that DA is 4, so we'll get to that in a minute. But first, let's look again at this bigger triangle. So we know that the hypotenuse is 15. So we see that the imaginary triangle, like we have our 3/4/5, right? There's a small hypotenuse of 5. This one is 15. We're like, oh, so this one has like a 3:1 ratio with our imaginary triangle, okay? The 3/4/5 that exists somewhere out of this angle. Whatever it is, like it's a 3/4/5, and the whole big triangle is 3 times as big, okay? So we've kind of drawn it to scale maybe, but I mean, no, we haven't, but we're just going to draw it here to imagine, right? So this hypotenuse is 3 times as big as our hypotenuse here, okay? So then we start to ask ourselves, what do we then know about the other sides of the big triangle? Well, if the 15 comes from 3 times 5, then what must this whole piece be based on 4? Well, it must be 12 because it also must have a 3:1 ratio. Yes? And then what must this piece be down here? Must be a 3:1 ratio at that 3. Well, it must be 9, right? 3:1. Okay. So we're like, well, that's all fine and good. It's nice to know that the bigger triangle is a 3:1 ratio with the small imaginary triangle, but we're looking for DE. And this is where the DA comes in. Okay. They tell you that DA is 4, right? We're like, well, DA is 4. Oh, well, that's interesting because we know that the whole thing is 12, right? So now we're starting to work on this, the top triangle, which is what we need because we need this top triangle, right? If DA is 4 and the whole thing's 12, what does DB have to be? Has to be 8, yeah? So that means between the big triangle, the small triangle, we know exactly then how to find out this piece. Like, what did we have to do? What's the ratio between our 3, 4, 5 triangle and then our top triangle here? It's 2 to 1, right? Because what's the difference between the 4 and the 8? 4 and the 8 is 2 to 1, right? So now, can we figure out DE? Yeah, again, 2 to 1, right? So what do we do to that 3? Multiply it by 2. We get 6. Okay. What would we do to the 5? Multiply it by 2. We get 10. If we needed it, we don't. DE is 6. So this is because we started out the imaginary 3, 4, 5 triangle that wasn't represented anywhere necessarily, just somewhere. There's a 3, 4, 5 triangle with the tangent ratio, right? Then they told us big hypotenuse is 15. And we're like, well, we have a 3, 4, 5. We have a hypotenuse of 5 and a hypotenuse of 15. That was our first Rosetta Stone. We're like, oh, so our little imaginary triangle up here, I shouldn't say imaginary, but it's like our ratio triangle, our reference triangle, has a hypotenuse of 5. The whole thing has a hypotenuse of 15. From there, we're like, oh, well then, if this side's 4, the whole thing must be 12 because we're multiplying by 3 to get from 5 to 15. 5 to 15. 4 times 3 is 12. 3 times 3 is 9. So we've got our 15, 9, 12. We want this piece, though. We want this top triangle. So then they tell us DA is 4. We think, oh, look at that. What's the relationship here? If this whole thing's 12, this is 4, this must be 8. What's the relationship between our reference triangle and the top triangle? It's double, right? So 4 doubled gives you 8 for this piece. 3 doubled gives you 6. 5 doubled gives you 10 if you needed it. The answer is 6. Please let me know if this doesn't make sense, if you have any questions. I greatly appreciate your patience. You're doing an excellent job. I look forward to talking to you again soon.